Hello students, how are you? So today we are going to start the center of mass chapter, right? Which chapter? Center of mass, right? What is center of mass? Center of mass is a point where we suppose that whole mass of that particular body is lying within that particular point. For example, if I take this stick, you see this is a uniformly distributed mass, means the density of this body is uniform at every each and section. If we take, so the density is going to be constant at every point, right? So we see the center of mass of this body is at the center, geometric center, right? This is a length, so we are assuming that at the half of this length there is a center of mass of this body, right? So if I pick this stick from this point, so it will hang like this. So it means the center of this body is at this particular point. It means when a uniformly distributed body is there and it is a known geometry, right? It's a symmetric body, right? In shape, I am saying, like a circle, like rectangle, like triangle. So the center of mass will be at the geometric center, right? So but you know, when the body is non-uniformly distributed, means the density is not constant, then the center of mass will be shifting towards the heavier masses, right? Let me show you one example. You see the center of mass is of this stick is here, but as I disturb the mass, the center of mass is going to be disturbed. How? Now you see, if I added some mass here and again I pick this stick from the center, no, it will not hold. You see, it is going down, so it means the center of mass is shifted somewhere else. Okay, maybe it is here, right? Let me check. No, it's not here. So the center of mass is shifted towards the heavier masses, right? So if I pick it from here, oh my god, I can see here it is shifted, means initially it was here at the center, now it is shifted towards the heavier masses, right? So the center of mass of a body lies where the heavier masses are there. And for known geometries and the uniformly distributed masses, means the density is constant. For example, we have the rectangle. This is a uniformly distributed mass, and we can say it's a known geometry, right? So where is the center of this body? If you make two diagonals where the two diagonal cuts each other, then there is a center of mass, right? Now but if we say, if we have system of masses, means in a box, let's say we have a box and there are so many masses in that particular box. So where is the center of mass of that particular box? So for that we have a one formula. Let's say we have so many masses, right? Like m1 mass is here, m2 mass is here, m3 mass is here, right? And m4 mass, let's say somewhere here. Okay, we have some system of masses. So I want to know where is the center of mass of this particular system. For that, let us assume, so this mass is positioned at r1 vector, right? And this m2 mass is positioned at r2 vector. This m3 mass is positioned at r3 vector, and this m4 mass is positioned at r4 vector. Actually, this r1, r2, r3 is showing the coordinates of this particular masses, right? So the center of mass, means the coordinate of the center of mass of this particular system will be m1 r1 vector plus m2 r2 vector plus m3 r3 vector plus m4 r4 vector divided by the total mass, that is m1 plus m2 plus m3 plus m4. And if we have more masses, then we can write it so on, m m5, m6 and so on, right? So this is the formula for the center of mass of the system. If we have so many masses, placed at R1, R2, R3 and R4 distance. Okay, let's say I want to know the x coordinate of the part as a center of mass. So for that we have x center of mass is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 and so on, divided by the m1 plus m2 plus m3 plus m4 and so on, right? In the same way we can write. And what is x1? What is x1? x1 is the coordinate of the center of mass of m1 mass, right? You need to understand, see, the mass can be big also. So in that case I need to understand the center of mass of m1. Okay, so x1 is the coordinate of the center of mass of m1, means x position, right? In the same way, what is y center of mass? Yes, tell me. m1 y1 plus m2 y2 and so on, divided by m1 plus m2 plus m3 plus m4, right? So in this way. Okay, let's understand this with one example. And for yz, z center of mass also you can write. Yes, tell me. m1 plus m1 z1 plus m2 z2 plus m3 z3 z3 and so on, divided by m1 plus m2 plus m3 and so on, right? Okay, let's understand this with one example. Okay, okay, now let's understand with one example. Let us say here it is m1 mass and here it is m2 mass, and these are kept at some distance, let's say L. Okay, so let us say this is 0 0. So here it is x1 and here it is x2. So obviously center of mass of these two masses will be lying somewhere here in somewhere between, right? So we need to find out the x coordinate of the center of mass. So x coordinate of center of mass will be m1 x1 plus m2 x2 by m1 plus m2. Now let us say, for example, we have two masses, like one m mass and one another mass, that is 4m mass, right? And these are kept at a distance of 20 meter, right? Okay, so what we'll do, we need to find out center of mass. So let's say one mass is kept at the origin. So what is the x coordinate of the center of mass? x1, it is 0. And what is the coordinate of the center of mass? x2 will be equal to 20, right? So now the x center of mass m1 x1. So what is m1? m1 is m. And what is x1? x1 here is 0. What is x2 beta here? x2 is 20 meter, right? Okay, so m1 x1 is 0 plus m2 is 4m into 20 divided by m1 plus m2. What is m1 plus m2? That is m plus 4m, right? So what this will be? 4m into 20 by 5m, right? So m and m cancel. So 4 5 is 20, 5 4 is 20. So 4 into 4, that is 16 meter. So x center of mass will be 16 meter from the origin. Here it will be somewhere here, 16 meter from here. So what is the coordinate of the center of mass? Tell me. Coordinate of center of mass will be 16 comma 0, right? I hope you understand. Now let us take one another example. It is given that 4 masses are kept on a vertex of a square. Okay, means 4 masses are arranged in a form of a square, like here the m mass, here also the m mass, here it is 2m mass, and here it is 2m mass, right? So let us say the side of the square is A. So what is the coordinate of the center of mass? Let us say here it is 0, 0. So here it is, what is m1? This is m. Let's say this is first mass, this is second mass, this is third mass, this is fourth mass. So m1 is m. What is m2? That is 2m. What is m3? That is again 2m. What is m4? That is again m, right? So what is x1? What is the coordinate of center of mass of m1? X1 is 0. What is x2? X2 here it is. Tell me, it is a comma 0. What is this? A comma a, and this is 0 comma a, right? So x2 is a. What is x3? X3 is again a, and what is x4? That is a. So what is the x center of mass? Tell me. So m1 x1 plus m2 x2 and so on divided by m1 plus m2 and so on. So m1 is how much? Tell me. M into 0 plus m2 is 2m into a plus x m3 x3 m3 x3 is 2m into a plus m4 x4, that is m into 0 divided by total mass. Total mass is how much? M plus 2m plus 2m plus m, right? I hope you are understanding. So this is 0, this is also 0, right? So now this is 2m into 2m, that is 4ma divided by how much it is? 2m plus 2m, this is 4m plus m, 6m. So that will be 2 by 3a, right? So it means somewhere here 2 by 3a. 2 by 3a here. Okay, x coordinate we got. So let's find out the y coordinate, y center of mass. So m1 y1 plus m2 y2 plus m3 y3 plus m4 y4, right? So ab dekh, now let's understand. So m1 is how much? M1 is m, and what is y1? Y1 is 0 plus m2. M2 is 2m, and what is y2? That is also 0 plus m3. M3 is 2m. What is y? That is a, and that is m4 into a, right? Divided by total mass is 6m, right? M, 2m, 2m, m, 6m. So now it is 0, it is also 0. So 2m plus m, that is 3m, right? 3ma divided by 6m. So that will be a by 2, right? So what is the coordinate of the center of mass? Tell me. Coordinate of the center of mass is, now what is x1? 2 by 3a, and y coordinate is a by 2. So this is the coordinate of the center of mass. I hope you are understanding, and thank you so much.